Alright, this video is going to be talking about strong acid base and the example that we're going to have on the test and on the worksheet you're going to be given shortly. So here's the example. This is example 1. And you're given 100 mils of a 0.02 molar solution of HCl. So we have a strong acid. And it's poured into a beaker containing 100 milliliters or 1 liter of 0.1 molar solution of lithium hydroxide. And there's 3 things we want you to do. One is write a balanced reaction, determine the amount of salt produced, and determine the pH of the final solution. So we want 3 sets of answers here. So what's important for us, and let me get my pen going. See blue. All right, so this is going to be important, and this is going to be important because this and this is our reagents, and we want to figure out what our products are. So let's go to the first slide. So this is going to be the balanced reaction. So when we're looking at the balanced reaction, we know we have HCl that's given to us, and we have lithium hydroxide. And we got to figure out what the products are. And with these, anytime we have a strong acid and a strong base, this is what will happen is that this will dissociate completely. So this is going to break apart and have H plus and Cl minus, and this is going to break apart to form La plus and OH minus. So what we're going to see is what we call a double displacement, where H and lithium will switch places with the anions, and we're going to have lithium chloride, and this is still going to be dissolved in solution, and we're going to actually have about a lot of water produced. Now, here's the thing. In the chemistry wide, this is an acidic solution, so the pH is going to be less than 7, and the pH of this is going to be greater than 7. When we add them together, we know we have a reaction because the pH is going to be approximately 7. This is what we mean by a neutralization reaction. Acid plus base gives me something neutral, and this is what we call a salt. So if everything was the same, we had the same number of moles of HCl, if the number of moles of HCl plus the equal number of moles of lithium hydroxide, and if these were equal to each other, and our product will be the number of moles of lithium chloride. So this number and this number and this number should be equal because they all should be balanced. And 1 mole of HCl plus 1 mole of lithium hydroxide will give me 1 mole of lithium chloride. That's how the reaction should work. But if we have if they're not balanced, I mean, if in other words we had different amounts, different moles of HCl and different moles of lithium hydroxide, we're going to end up with a limiting reagent problem, and we've got to figure out how much of this we're going to make, and whatever is in excess, what the pH is going to be. Now, for my final reaction, this is what you need to put on your paper. It's HCl plus lithium hydroxide will go to lithium chloride, and this is aqueous plus H2O. And since these are in solutions, these are aqueous as well. So this is the answer for the first problem. The second is the amount of salt. Now, from up here, this is our salt, lithium chloride. So we're looking for the amount of lithium chloride. And if you put it into moles, that's fine. But usually we may want grams because that's what we measure things in, its mass. So let's look at we had the reaction from the last slide, which I'm going to put down. And honestly, it doesn't matter which way you write the reagents, it's still going to be the same reaction. Now, here's the thing. For lithium hydroxide, we had, let me come up here, 0.1 times 100 mils. 0.1 molar of lithium hydroxide, and we got 100 mils. And we want to convert that to liters. So 1 liter is equal to 1,000 milliliters. And we're going to end up with 0.01 moles of lithium hydroxide in this solution. And we're going to add that to a 0.02 molar solution of HCl. That's moles per liter. And of course, the same calculation. We had 100 milliliters over 1. And that's 1 liter over 1,000 milliliters. And that's going to give me 0.002 moles of HCl. Now, this is what we call the limiting reaction problem. So so we want to know how much of the salt's going to be made. And it's a one-to-one relationship. So 1 mole of lithium chloride is related to 1 mole of LiOH. And that's going to be 0.01 moles of lithium chloride. This is going to make 0.002 moles of lithium chloride. So with this calculation, all I'm doing is changing using the molar ratio, the one-to-one relationship, to figure out how many moles of lithium chloride I'm going to make if all this reacts and then all this reacts. And you notice this is my limiting reagent. It's going to be HCl because I'm only going to make 0.002 moles of lithium chloride. So for my answer here, the amount of salt I made is going to be 0.002 moles of lithium chloride. If I want to change that to grams, the molecular weight is lithium is 6.94 and chloride is 3545. So that's 6, that's 13, that's 12, that's 42.36 grams per mole. So what we do is to take 0.002 grams times 1 mole is to 42.36. 6 grams. Whoops, and I made, this is moles, sorry. See, don't do what I just did. So let me go down here, go to the next slide. 0.002 moles, make sure you get this right, of LiCl. And we need 42.36 grams per mole of lithium chloride. Moles cancel, and then we end up with mass. And so get my handy dandy calculator out, and you go 0.002 times 42.36, and you're going to get 0.0847 grams of lithium chloride being produced. And so this is your answer for number 2. This is what we're looking for. Now come back up here to the third, determine the pH of the final solution. All right, this is where these two problems come into being. So we know we have lithium hydroxide's excess, so this is going to be a basic solution because we've got more lithium hydroxide than HCl. How much more? Well, we got to figure out how many moles of LiOH is left. So we've got 0.01 moles of LiOH, and 0.002 of it reacts with HCl and goes away. So we've got 0.008 moles of lithium hydroxide left. Okay? So far, so good. Now, total volume is going to be 100 milliliters plus 100 milliliters gives me 200 milliliters. Or, let's get this into liters, 0.2 liters. So there's the volume, here's our concentration. So the concentration of LiOH in solution is going to be 0.008. That's how much moles of lithium hydroxide is left, divided by 0.2 liters. And we're going to get a concentration of 0.04 moles of molar of lithium hydroxide. Now this is the concentration of OH in there, because remember this dissociates completely. So now 0.04 moles, take the negative pH of this, so we need the minus log of this. So minus log of concentration of OH minus equals the POH, which is equal to, so we take 0.04, take the logarithm of that, then the minus sign, and you get 1.40 is the POH. 14 pH plus POH is equal to 14. The pH is equal to 14 minus POH, which gives me a value of 12.4. And here's the answer to my last question. What's the pH of the solution? And this is how you solve these type of problems. Let's go back. 1, I want the balanced reaction. There's the balanced reaction. I'm doing this so give you guys an idea how to solve these problems in college if you continue on with chemistry or science. Here's the balanced reaction. Boom, boom, boom. Acid-base chemistry, neutralization reaction, you get a salt and water. All right, how much salt is made? This is a limiting reagent problem. Figure out how much lithium chloride is made if you react all of this and all of this, and you notice everything's a one-to-one relationship. I'm going to make the least amount I'm going to make is 0.002, so HCl is my limiting reagent. Carry this forward to mass, and this is how much salt I make. Now, to figure out the pH of the solution, everything is made. You take the limiting reagent, subtract it from the excess to figure out how many moles of LiOH is used up. Since it's a one-to-one relationship, you get that number. Figure out the total volume, and then divide the two to get the lithium concentration of lithium hydroxide. But then again, that's POH, which is fairly low, but we want the pH. And this is what this calculation does. I hope this helps. You're going to get a practice set about 3 problems in this. Go ahead and work through them all and submit the paper to me by email. Thank you, guys.